Hello, mathematicians. Today we're going to be learning about exponents, more specifically about evaluating exponents with decimals. To get us started, we have 2/10 to the power of 4. And in order to evaluate this expression, the first thing we need to do is write 2/10 to the power of 4 as repeated multiplication. And in this case, our base is 2/10, which we'll use as a repeated factor 4 times because our exponent is 4. That means that 2/10 to the power of 4 is equal to 2/10 times 2/10 times 2/10 times 2/10. Then, in order to evaluate, we're going to go ahead and multiply. Now, if you struggle with multiplying with decimals, we can go over this trick where we temporarily write 2/10 times 2/10 times 2/10 times 2/10 without the decimal points and just go ahead and multiply. So that means we write 2/10 times 2/10 times 2/10 times 2/10 as 2 times 2 times 2 times 2. So let's go ahead and multiply. 2 times 2 is equal to 4, and we've multiplied 2 by itself, and so we're going to go ahead and multiply it by another 2, which makes that 3. So 4 times 2 is equal to 8, and then we're going to go ahead and multiply it by another 2 because we have 4 2's in total, and 8 times 2 is equal to 16. So 2 times 2 times 2 times 2 is equal to 16. So now let's go back and incorporate our decimals. Now, if we go back to 2/10 times 2/10 times 2/10 times 2/10, the first thing we want to do is count how many digits we have in total after every single decimal point. So here we have 1, here we have 2, 3, 4. So we have 4 digits in total after our decimal points. We're going to write our answer, which was 16, and we're going to put a decimal point at the end of it because it goes at the end of every whole number. So for example, if I wanted to write $16, I would write 16.00, just like any other whole number. That's where it goes. However, we're going to move the decimal 4 spaces to the left for our final answer. So, 1, 2, 3, 4. Notice that we have blank spaces here. We're going to add zeros to fill in those blank spaces, and then we're going to move our decimal points. And what we also need to do is add a 0 if the decimal point doesn't have any digit before it. So our final answer when we multiply 2/10 times 2/10 times 2/10 times 2/10 is 16/10,000ths. So let's recap what we did. So 2/10 to the power of 4, in order to evaluate this expression, the first thing we need to do is write 2/10 to the power of 4 as repeated multiplication. So 2/10 to the power of 4 is equal to 2/10 times 2/10 times 2/10 times 2/10. The reason we use 2/10 as a repeated factor is because that is the base. The reason we write it out 4 times is because that is our exponent. Our exponent tells us to write out our base 4 times. For step 2, we're going to go ahead and multiply 2/10 times 2/10 times 2/10 times 2/10, and we get 16/10,000ths. So our final step is to write a numerical equation showing that 2/10 to the power of 4 and 16/10,000ths are equivalent. So 2/10 to the power of 4 is equal to 16/10,000ths. Here we have another example, which is 4500ths to the power of 2, or we could also read this as 4500 squared. And the first thing we need to do is write this out as repeated multiplication. So our base is 45 hundredths. So we'll be using that as a repeated factor 2 times because our exponent is 2. So 45 hundredths to the power of 2 is equal to 45 hundredths times 45 hundredths. So the next thing we're going to do is multiply. Now, if you struggle with multiplying with decimals, you can temporarily write 45 hundredths times 45 hundredths without the decimal points and then go ahead and multiply. So that means we're going to write 45 hundredths times 45 hundredths as 45 times 45. And then we're going to go ahead and multiply normally. So 5 times 5 is equal to 25. We're going to bring down the 5 and bring up the 2. Then 5 times 4 is equal to 20. Don't forget to add the 2, and we get 22. And then we're going to add a place value holder of 0, and then we're going to multiply with this 4. So 4 times 5 is 20. Bring down the 0, bring up the 2. 4 times 4 is 16. Don't forget to add the 2, and then we get 18. So let's go ahead and now add. 5 plus 0 is equal to 5. 2 plus 0 is equal to 2. 2 plus 8 is equal to 10. Bring down the 0, carry over the 1. 1 plus 1 is equal to 2. And so that means that 45 times 45 is equal to 2025. Now let's go ahead and revisit our decimals. So we're going to look at 45 hundredths times 45 hundredths. And the first thing we want to do is see how many digits we have in total after the decimals. So here we have 2 digits. Here we have 2 digits. So in total, we have 4 digits after the decimal points. So we're going to write our answer here, which was 2025, and put a decimal at the very end because whenever we have a whole number, the decimal goes at the end. And then we're going to move the decimal 4 spaces to the left for our final answer. And that's because we have 4 digits in total after our decimal points in 45 hundredths times 45 hundredths. So let's go ahead and move it. 1, 2, 3, 4. So we're going to go ahead and move our decimal. And then because there's nothing before the decimal, we're going to go ahead and add a 0. So 45 hundredths times 45 hundredths is equal to 2025 ten thousandths. So let's recap. We have 45 hundredths squared, and in order to evaluate this expression, the first thing we did was write 45 hundredths squared as repeated multiplication. So that means that 45 hundredths squared is equal to 45 hundredths times 45 hundredths. Then we're going to go ahead and multiply. So 45 hundredths times 45 hundredths, and we got 2025 ten thousandths. Then finally, we're going to write a numerical equation showing that 45 hundredths squared and 2025 ten thousandths are equivalent. So that means that 45 hundredths squared is equal to 2025 ten thousandths. Here we have another example, which is 1 5/10 to the power of 3, or we could read this as 1 5/10 cubed. In order to evaluate this expression, the first thing we need to do is write 1 5/10 cubed using repeated multiplication. So that means we're going to take our base 1 5/10 and write it out 3 times because our exponent is 3. So 1 5/10 is a repeated factor 3 times. That means that 1 5/10 cubed is equal to 1 5/10 times 1 and 5/10 times 1 and 5/10. Now we're going to go ahead and multiply. Now again, if you struggle with multiplication with decimals, we're going to temporarily write 1 and 5/10 times 1 and 5/10 times 1 and 5/10 without the decimal points and multiply. So that means that we write 1 and 5/10 times 1 and 5/10 times 1 and 5/10 as 15 times 15 times 15. So we're going to go ahead and start multiplying 15 times 15. 5 times 5 is equal to 25, so we bring down the 5 and we carry over the 2. Then 5 times 1 is 5, add the 2 and we get 7. Then we're going to add a place value holder, a 0, and then we're going to go ahead and multiply with our 1. So 1 times 5 is equal to 5, and 1 times 1 is equal to 1. So now we're going to go ahead and add. 5 plus 0 is 5. 7 plus 5 is 12. So we bring down the 2 and carry over the 1. And 1 plus 1 is equal to 2. So that means that 15 times 15 is equal to 225. We're going to take that product and multiply it by another 15 because we're multiplying 15 times 15 times 15. And we're going to go ahead and multiply. 5 times 5 is 25. Bring down the 5, carry over the 2. 5 times 2 is 10, plus 2 is equal to 12. So bring down the 2 and carry over the 1. And then 5 times 2 is equal to 10, plus the 1 on top, that's equal to 11. So now we're going to add a place value holder, and we're going to multiply using the 1. 1 times 5 is equal to 5. 1 times 2 is equal to 2. And 1 times 2 is equal to 2. So now let's go ahead and add. 5 plus 0 is equal to 5. 2 plus 5 is equal to 7. 1 plus 2 is equal to 3. And 1 plus 2 is equal to 3. So that means that 15 times 15 times 15 is equal to 3,375. Now let's go back and revisit 1 and 5/10 cubed. Now we know that's equivalent to 1 and 5/10 times 1 and 5/10 times 1 and 5/10. So the first thing we're going to do is see how many digits we have in total after our decimals. So here we have 1, 2, 3. So we have 3 digits in total after our decimal points. That means we're going to take our answer, which is 3,375, and put a decimal where it belongs because it's a whole number. It goes at the end. And now we're going to go ahead and move the decimal 3 spaces to the left for our final answer. So 1, 2, 3. And then we're going to go ahead and move our decimal. So 1 and 5/10 times 1 and 5/10 times 1 and 5/10 is equal to 3 and 375 thousandths. So let's recap. We started off with 1 and 5/10 to the power of 3, or we could read that as 1 and 5/10 cubed. And then the first step was to write 1 and 5/10 cubed as repeated multiplication, meaning that 1 and 5/10 cubed is equal to 1 and 5/10 times 1 and 5/10 times 1 and 5/10. Then we're going to go ahead and multiply. So 1 and 5/10 times 1 and 5/10 times 1 and 5/10 is equal to 3 and 375 thousandths. Finally, we're going to write a numerical equation showing that 1 and 5/10 cubed and 3 and 375 thousandths are equivalent. So that means that 1 and 5/10 cubed is equal to 3 and 375 thousandths. Here we have our final example, which is 2 and 300ths to the power of 2, or we could read this as 2 and 300 squared. The first thing we need to do to evaluate this expression is write it using repeated multiplication. Our base is 2 and 300ths, so we're going to use that as a repeated factor. And our exponent is 2, which tells us how many times to write 2 3/100. So that means that 2 3/100 squared is equal to 2 3/100 times 2 3/100. Then we're going to go ahead and multiply. So we're going to temporarily write 2 3/100 times 2 3/100 without the decimal points and multiply. That means we write 2 3/100 times 2 3/100 as 203 times 203. Now we're going to go ahead and multiply. So 3 times 3 is equal to 9. 3 times 0 is equal to 0. 3 times 2 is equal to 6. And then before we go ahead and multiply with our 0, we're going to add a 0 as a place value holder. And now 0 times 3 is 0. 0 times 0 is 0. And 0 times 2 is 0. All right, and now we're going to add 2 place value holders because we're going to go ahead and multiply with our 2. So 2 times 3 is equal to 6. 2 times 0 is 0. And 2 times 2 is 4. So now let's go ahead and add. 9 plus 0 plus 0 is equal to 9. 0 plus 0 plus 0 is 0. 6 plus 0 plus 6 is equal to 12. Bring down the 2. Carry over the 1. 1 plus 0 plus 0 is equal to 1. And then just bring down the 4. So that means that 203 times 203 is equal to 41,209. So let's go ahead and revisit 2 3/100 to the power of 2. We know it's equivalent to 2 3/100 times 2 3/100. So let's go ahead and see how many digits we have after our decimal point. So here we have 2. Here we have 2 more. So in total, we have 4. So we have 4 total digits after our decimal points. So we're going to take our answer. We're going to put a decimal at the end, and we're going to move the decimal 4 spaces to the left for our final answer. So 1, 2, 3, 4. And then we're going to move our decimal. So that means that 2 3/100 squared is equal to 4 1,209 10,000ths. So let's recap. Here we have 2 3/100 to the power of 2, or we could read this as 2 3/100 squared. The first thing we need to do to evaluate this expression is write 2 3/100 squared as repeated multiplication. Our base is 2 3/100, so we're going to use that as a repeated factor. And our exponent is 2, so we're going to write it out 2 times. That means that 2 3/100 squared is equal to 2 3/100 times 2 3/100. Then we're going to go ahead and multiply. 2 3/100 times 2 3/100 is equal to 4 1,209 10,000ths. Finally, we're going to write a numerical equation showing that 2 3/100 squared and 4 1,209 10,000ths are equivalent. So that means that 2 3/100 squared is equal to 4 1,209 10,000ths. And that's it.